Hello and welcome everyone. Welcome to this talk that's called Building Resilient Cloud Applications with Chaos Engineering and Azure Chaos Studio. My name is Geert van Cruijsen. I'm from the Netherlands, where I work for a company called Geert, where I work as a consultant helping other companies build better software in the general sense. So I help them set up better cloud architectures, help them build better resilient software architectures, and also help them implement DevOps practices. So today we're going to talk about chaos engineering. Why do we need chaos engineering? Well, software is becoming more and more important in our lives and our societies, right? And especially software outages are also having a really big impact in our society, either money-wise, but also having a really impactful thing like this example where Delta Airlines had an outage and all the flights had to be cancelled. That impacts Delta as a company, but it also impacts a lot of people who wanted to travel who were not being able to. So with chaos engineering, we're going to try to build more resilient applications. So let's have a look at these two images. Do you know what these are? Well, let me explain to you. These are actually the network architectures of two very big web applications. One is Amazon.com, the web shop, and on the other hand, it's Netflix. So looking at these complex applications, how do you make sure that these complex applications are actually resilient to failure? Well, the answer is simple. You can't. You need to make sure that your users are impacted the least, even when things go wrong, because you can't guarantee that all of these different nodes within this application actually all are all working at the time that a user is using your application, especially in a 24/7 scenario. And of course, you might say, well, my application is not that complex as Amazon.com or Netflix. But I just browsed through some cloud architecture diagrams on the internet, and I found some examples here that do have quite a lot of different components. And often these different components have different release cycles, so they're deployed at different moments. They all communicate through the network, which we all know is not reliable. So having your application up and running in the cloud as a distributed application, you need to make sure that your application is actually delivering value to your customers, even if things go wrong, because things will go wrong. We really need to make a mindset shift that we need to move to a place where when we're building in a complex landscape, our application is never fully up, but how are my users impacted by that? Can my users still use my application even if my application landscape is not fully up? This is really a big change for a lot of us building and running applications. So also we need to change how we monitor our tools. Just doing technical measurements is not enough. Technical measurements might show up that certain things are down, but how are our users impacted? So really measuring how our users are being impacted is key here. So how do we measure this user impact? Well, here are some examples of how you can do it. How can you measure reliability? Well, one simple example is measuring availability. Let's say we have a web application. Measuring the amount of 200 OKs compared to 500 application errors gives you a great overview of how your application is actually doing. But availability is only one area of your application. What if the pages take really, really long to load? So our latency is really high. In the end, the page might load, but people might already left to your competition because the pages load so slow. So latency is also an aspect that we want to take into account. Then there's things like throughput, correctness, freshness. We want to make sure that the actual results that we're showing on the page are also the correct data. It might be that we have a search page that's showing up really fast with the results, but it says, well, no results found, while there were actually results to be found. So the correctness of that data that you're giving to your customer is also really key. Then there's also other measurements that are more internally, like coverage, quality, and durability. There are less focus on user impact, so we're not diving into those deeper. And then we want to build resilient applications. So what are the things that could go wrong with our applications? And well, that can go over all kinds of different areas, right? Well, the first thing that could go wrong is things happening to your infrastructure. Certain services might be down, or your cloud provider might be updating the underlying infrastructure. Certain deployments might be made to the infrastructure, or config changes might happen that break your infrastructure. Then we all know the network. The network is never reliable. There might be packet loss. There might be certain latency happening within your application. How's your application being able to cope with those kind of things? Then the application itself. We as developers, we do make mistakes, right? We introduce bugs. We make some things that don't work as supposed to in our application. So, well, we're also a big part of how resilient our application is. And then, of course, we have people. People next to developers interacting with the application, maybe changing certain config values, etc., might also break your application. So we know that our application can fail on all these different types that could go wrong. But how do we actually handle those? Well, one thing is that we should really focus on failing in a way that we impact our users the least. So failing in a way that our users are impacted, well, preferably not at all. A great example that I always like to use is looking at a authentication server. So for most of the applications that I know, if the authentication server fails, you can't do anything, because that's the first thing that you do when you're trying to use the application. You first need to log in, and from there on you can actually start using the application. What Netflix did is they tried to solve this problem. So how can we make sure that our users are impacted the least when authentication server fails? So what they did is, if the authentication server fails because they introduced a problem in the infrastructure or network or whatever, then they just open up the whole catalog of videos and everyone can watch the videos even without logging in. So users are not impacted. Well, they might not see their history of viewed things, but they can still browse the catalog and start a episode or movie manually. So they really thought about, how can I impact my users the least when certain things go wrong. And I really would like to think about your own applications that you're building to see how can you implement those kind of patterns in your applications as well. And this doesn't mean that if you're working for a bank, then you should just open up all the bank accounts if people can't log in. But there might be other scenarios that do work for you. So then, more into chaos engineering. What does chaos engineering mean? I really like to compare it to vaccinations. So what vaccinations do is you inject a little bit of harm into your body to see how your body is being able to withstand those certain that little bit of harm that you injected into your body. And from there, your body can learn from it. So when the actual harm of a disease enters your body already knows how to deal with it and doesn't make you sick. And that's exactly the same thing as we do with chaos engineering, where we inject a little bit of harm into our applications in a controlled way. So when things might really go down, then we already know how to deal with it. So what chaos engineering is not is just random killing servers in production, because that's what I often hear when I ask people, what is chaos engineering? That's the opposite of chaos engineering. It's just chaos without the engineering part. So let's look at the official definition for chaos engineering created by the chaos engineering community, which is stated on the principlesofchaos.org. What they came up with is chaos engineering is the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. Well, that's a big mouthful, so let's focus on the 3 key areas of that sentence. It's about experimenting to build confidence to withstand turbulent conditions. And experimenting is really the key thing here. So we're going to do experiments, which is something different compared to tests. If you look at tests, we have a fixed outcome and we have a fixed starting point. And we want to verify that the outcome is exactly what we expected it to be. With experiments, we have a fixed starting point and we have a hypothesis of things that should happen when certain things arise. But it's not that we can just verify it by like doing a test. We need to do an experiment to see what will actually happen. So what that looks like is maybe something like this, where we have multiple services communicating to each other, and then in between those services we can inject a little bit of harm, even with in between those services or in one of those services itself. Maybe add some latency, maybe make one of those services crash to see what happens. So what kind of experiments can we actually do? As I just said, we can make one of those services crash, make one of the hosts fail. We can do resource capacity attacks, so make the CPU usage or memory pressure really high in one of those services to see what happens. We can inject some application failure, so let one of the services return error codes to see how the other service copes with that. We can add things to the network, add some latency, add packet loss, all those kind of things to see how our application deals with that. And then we have something that I like to call the brand attack. It's the human factor of attacks. We all have this brand person within the company that we all go to when certain things go wrong in production. He's the person that always helps you fix the issues really fast and making sure that the user impact is the least. Brent is actually a fictional character from the Phoenix project, where he is the person that actually does all these things. But what happens when this person is on vacation? What happens if he or she quits his or her job? How do you still deal with these kind of things? Well, these experiments are actually the easiest to do, but just having that person sit in the back while other people within the company are trying to solve certain issues, to see if we have the right knowledge into the minds of other people as well. So these chaos experiments, do we really need to do these in production? Well, production is the place where we actually add value to our end users, so it might be the place where we want to have the most confidence about. But of course, when chaos engineering is new for you, starting off in production is often not the right thing. Right? So starting off in an environment that's least impactful might build up some confidence, so in a later stage you can actually do this in production as well. So how do we start our first experiment? Within chaos engineering, we like to call this a game day, where we get everyone in the office or everyone in a remote call, so everyone is actually involved. When something goes wrong, then we can actually help each other to fix it. And then we do something that that looks like something that you might already be doing if you're doing incident response learning. That I see a lot of DevOps teams already implementing when certain outages appear. So a normal routine in incident response learning is you have a normal state, then you have an outage, and this outage often appears on a Friday night or Saturday night when the least amount of people are working. Then we detect the outage, do analysis of what's wrong, we implement a fix, we do a post-mortem or learn from how we can actually not have this happen in the future, and then we improve so it doesn't happen in the future again. And then we're in our normal stage again, and then we wait until a certain outage appears. With chaos engineering, when we do a game day, we actually plan these outages. So we have exactly the same routine, but then with everyone being on standby or in a call, we can actually inject this little bit of harm to see how our application copes with it. And we can have everyone there to help fix the issues when they might appear. So let's look at a little bit of more details about how these chaos experiments look like. First of all, we start with a steady state. We all need a steady state to actually do certain experiments on. Then on that steady state, we define a hypothesis. Then we design and execute an experiment. We learn from it, and then we fix things that might be improved in the future. So let's start off with our steady state. We really need to know what the current business metrics are, or how our users are experiencing our application. In this example, Amazon saw a drop of sale of 1% when they added 100 millisecond load time of their pages. And you say, well, 1% is not that much, but if you're looking at the volumes that Amazon is processing, this is quite a lot of money. So knowing what the load time is to start with is really key. So really knowing all the business metrics that you want to measure, you need to have those ready before you can start doing any experiments. And then you need to have some form of controlling the flow of your applications. Let's say we have a certain service that we want to do our experiments on. If we have control of the network routing, we could create multiple instances of this service, so we can actually make one service the control service, which is just a control group to see what happens if nothing would happen, but we might add some extra observability, extra logging, those kind of things. And then we have the experiment service, where we actually start doing these experiments on. And then by routing the traffic, sending the same amount of traffic to our control service and the experiment service, we can start seeing if there are any changes in how these services behave. And then we start designing on our experiment to actually inject harm into this experiment service. And when we design these experiments, you always need to make sure that you're always ready to abort. So there might things happen that you didn't think of. There might be all kind of cascading errors going to other systems that you didn't take into account. So being able to quit the experiment immediately is really key. So then we're going to define our hypothesis. So what we're going to do is we get everyone together who is involved in building and running the applications. So from developers to operations, people involved in the network or infrastructure, but also business people that know what the impact would be when certain people are hit by outages. And then you start brainstorming of things that could go wrong and how your application should be able to withstand those. So let's say, what happens if our database goes down? And then come up with hypothesis that if the database goes down, our users should not be impacted because we have certain measures in place. So we're only going to design experiments that we already created extra resiliency into it. Let's say if the database is down, well, we still have a caching layer that that will give us the results, so users are not impacted by not being able to do queries, and all the changes, they will be stored in some temporary place. Then when the database comes up again, then we can process them. If you have those kind of things in place, then we can start doing the experiment on that. Never do experiments that you already know will break. If you know, well, if our database goes down, then our application does not work anymore. But we don't have to do an experiment because we already know that it will fail. You can skip immediately to the fix phase where we start implementing these resiliency patterns to make our application actually being able to withstand these conditions if that's important to your business case. So then we're going to design and execute our experiment. When we're designing our experiment, first of all, we need to start small. Let's make as least impact as possible to at least see that our application is able to withstand that. And if everything goes well, then we can gradually move to a bigger blast radius, make the impact a bit larger, and make sure that everyone who's involved in building and running the application is actually involved and knows that these experiments are being executed on a certain environment. And then we can actually use all kinds of tools to help us do these experiments. Some examples that you might already know are Gremlin, which is a commercial product. It's a SaaS product that you can just buy and that help you to design these experiments. But there's also open source tools like Chaos Toolkit or Chaos Mesh, where Chaos Mesh is really a service mesh on Kubernetes that helps you implement chaos within the Kubernetes cluster. And Microsoft last year, they started with Azure Chaos Studio, which is just a SaaS solution coming out of the box with their cloud platform. So you don't have to buy any tools to inject those kind of harms to see your application is doing, especially if you're using Azure PaaS services, which are not being able to test with other commercial products. Azure Chaos Studio is actually working together with Chaos Mesh. So if you're running a Kubernetes cluster on Azure, all the experiments on Kubernetes are being done through Chaos Mesh. Let's have a quick demo of Azure Chaos Studio and what you can actually do with it. So what I have here is an application that has a to-do list. And that to-do list is powered by a Cosmos DB, where that stores all the data. And it has data stored in West Europe and in Australia Southeast. And what I can do from Azure Chaos Studio is I can design a number of experiments. So let's look at this experiment that I have already created. If I edit it, what you can actually do is you can create a workflow of all the steps that define your experiment. And in those steps, you can add certain actions. So let's look at all the different types of actions that you have. So things that you could do is inject chaos into your Kubernetes cluster by either killing pods or adding kernel chaos or maybe latency within the AKS network. But we can also do things on virtual machines, for example, do CPU pressure or memory, or have DNS failures. And the nice thing is that Azure Chaos Studio can do is work with Azure Platform as a Service services. So, for example, Cosmos DB failovers. And as I said, I have this to-do application that's being powered by my Cosmos DB. So if I go to this experiment, what we're actually going to do is have it fail over to a different region. So let me start the experiment. And we also need to do an actual test so that it's actually working. So what I did is I created this script here that does communicate with my API of the web application, inserting new to-do items directly through the API. And what it's doing now is it is communicating with my Cosmos DB through the application, and the Cosmos DB is running in West Europe. So, well, West Europe is really close to where I am. West Europe is in Amsterdam. I'm in the Netherlands as well. So if you look at the script that's running, you can see that there's well, the latency is quite low. But now when we're doing the experiment, we're going to do a failover to our different regions. So it's going to kill our region in West Europe and it's going to fail over to Australia Southeast, which I configured as our failover scenario. Normally, of course, you would pick a region that's closer by home, but for the demo purposes, I've chosen the one that's furthest away for us, so it's actually visible in the demo. So this is taking a while. Oh, it's actually just happened here. So my hypothesis was that my users would not be impacted even if there would be a failure in West Europe, and there would be an automatic failover to my second region. And if you can see here, I did not see any failures in my calls, but I saw one call taking 6 seconds. So that was actually being withheld at the server side and then moved to the other server. And from there on, it's communicating with my server in Australia, which is looking to be a lot further away. So the latency is a lot higher. Well, latency might be something that I'm okay with, since I can still use my application even though it's a bit slower and there's an outage. And if this region would be a lot closer by, the impact would be a lot less. So these are the cool things that you can do with Azure Chaos Studio without using actually a separate product. It's just coming out of the box where you can just select a new experiment. And within the experiment, you can just select one of the resources within Azure and try to do those experiments on them, which is a really good starting point. And from there on, you might move to other products if you really need more advanced scenarios. So from there on, we start our learning phase. We've seen the experiment, we've seen the outcome. Then we need to learn from the actual outcomes. How fast were we able to recover from our outages? They might need certain manual overrides, or did we have our automated controls in place, and how long did they take to actually overcome this problem? But also, how fast were we able to detect certain outages? Were we able to respond in time before users were actually impacted? And the key thing here is you've designed this experiment together as a team. So do not blame someone for being the problem. As a group, you were confident that your application was able to withstand those conditions. But well, things happened that were different. So learn from that as together and see it as really as a learning to improve your application afterwards. And that's the last phase, actually fixing your application, making the application better so it is able to withstand in the next run. And then after that, rerun the experiment to see if your changes actually do work and how your users are impacted by then. So looking at the time, making your application resilient also requires your architecture really to be resilient. So there's a number of patterns, which I'll just list a number here, which you can dive into further, which are basically a session by itself, but really looking into adding multi-parallelism, so having multiple pieces of infrastructure doing the same. So if one goes down, then the other can take over. Adding asynchronous communication, so you do not rely on two systems really tightly coupled together. Things like the outbox pattern, queue-based load leveling, so you don't have that much impact on your databases. But adding idempotent APIs, so you can actually do retries more easily. Do things like circuit breakers. So if things go wrong, you don't keep on trying that path that does not work, but actually move to a different route that does work or does impact your users the least. So keeping these patterns in mind are really key, and there's really good documentation on how to implement those patterns if you search for those terms. So with that, I would like to wrap up this talk. First of all, if you want to start doing chaos engineering, it's often quite easy to do that within your own team scope. But if you want to do this in a broader scope, it really needs to have a big culture change for a lot of companies where you really have DevOps teams building and running the application from start to end, and have people who are involved in making the application work well in all circumstances. And then just start doing these experiments. Try a couple of those tools that I've shown you in the list, and try to do some experiments to see how your application is being able to withstand turbulent conditions. Make sure you have the right observability in place so you actually know how your application is doing in these conditions. And with that, I would like to end with a quote by Nora Jones, who wrote a couple of chaos engineering books. And the quote is, "Chaos engineering does not cause problems, it just reveals them." Thank you very much.
Hi, Geert.
Hello.
Hi. Nice to see you.
Yeah, thank you. Thanks for having me.
I see you are home now. Yeah, yes, because I know you was in trip also. Welcome back home. So we have a few minutes for questions, and the first one is, what are the principles of chaos engineering?
What are the principles of chaos engineering?
Yes.
The principles is basically the idea is that you want to build more resilient software, right? So you want to have least impact of your software when things go wrong on your end customers. So the principles of chaos engineering are written down by the community, created together by the community to define how we can do this by using chaos engineering.
Okay. And the next one, almost like the same. What are the best practices for chaos engineering?
Yeah, so there's a lot of best practices. I would advise, and when you want to start doing these kind of things, is as I just said in the talk, starting small, trying to see if you've built certain things that where you've added resiliency to your application. So let's say you build a failover scenario when stuff goes wrong, to actually try to make an experiment that actually verifies that. So you actually know that those things are working.
Okay, for now in our chat I don't see any more questions, but I think maybe someone wants to join us in the Discord voice channel and will talk with you there. So please join, and yeah, we can move in Discord. And thank you guys.